Alright, so here we have practice test 1, question number 3. Given that heptene, and they give you the formula, combusts at STP, write the balanced equation for the reaction. You don't need your physical states, and then we're going to do a conversion. Alright, so for this, we know it's C7H14 plus what? Good, O2 yields and H2O. Okay, so then you balanced it, and it was a trickier one, right? You actually had to double this one on the end. So it's 2, and then oxygen was 21, carbon dioxide 14. Good, 14 and 14. All right, great. Okay, so we balanced it. Everybody's cool with that, right? Given 10 liters of that heptene, how many liters of oxygen are required? So we start off with 10 liters, C7H14. And then what do we put on the bottom? Good. Good, yeah. Liters of C7H14, and I heard 22.4. Why can we use 22.4? Yeah, good, and it says it's at STP. Alright, which all the problems will this chapter, alright, but just keep that in mind. So 22.4 liters of heptene equals, good, 1 mole of heptene. Alright. And what do we put on the bottom now? James, what's up?
What does STP mean again?
Standard temperature and pressure. So when we assume that we're at STP, that means this problem is under the conditions of 0 degrees Celsius and a pressure of 1 atm, which it's always going to say that in this chapter, yeah. The reason that it says that is because if it wasn't at that, like, and the temperature increased, the volume would increase as well, because again, if you heat something up, it's going to expand more if it's a gas. So that's why we're just going to assume this whole chapter we're at STP, just to make it simple, all right? Okay, so now on the bottom here, we're going to have moles of the heptene, right? How many? 2. Where'd you get the 2 from? Yeah, the equation, good. And then what's going to go on the top? Good, 21 moles of oxygen. All right, and what are we looking for? Yeah, volume of oxygen, liters of oxygen, good. So we'll have, how many moles on the bottom for this?
1.
Good, 1 mole of oxygen on the bottom, and on the top? 22.4 liters of oxygen on the top. Great, okay, so what can we cancel out? Yeah, we can cancel out the number 22.4. We can also cancel out all the units, right? Liters of heptene, moles of heptene, moles of oxygen, leaving us with liters of oxygen, all right? And now to solve the problem, we just do 10 times 21, which is 210, divided by 2, which is 105. Yeah, exactly. Good. So we didn't even need a calculator. Is that the right number of sig figs? 105? Well, you were quick to say no, but it is, right? We have 3 sig figs. 3 sig figs.
Really?
That's funny.
So like 1 mole equals.
All right, good?
22.
Yeah.
If you were given like 10.00, where there's 4 sig figs,
Yeah, 4 sig
but there is 22.4, which are like 3 sig figs.
Oh, okay. I see what you're saying. For us, whenever you're doing conversion factors, you just assume they have an unlimited number of sig figs. They don't go into our kind of consideration for sig figs. Just look at whatever's given in the problem and use the sig figs from that. Okay? Yeah, so if this had 4, our answer would have 4. All right? Any other questions with that? No? Okay. Okay, so now here's where the problem gets to the new format. It says if you had 150 liters of oxygen to start, is oxygen the limiting reactant or the excess reactant? What did we just find out?
How much we needed.
Yeah, we need 105 liters of oxygen, right? So if we need 105 liters of oxygen and we have 150, it didn't switch, 150, come on, and we had 150, do we have enough oxygen? Yeah, we do, right? So oxygen is the excess. Yeah, okay. So oxygens are excess. All right. How many liters of the excess remain at the conclusion of the burn? So at the end of the reaction. What do we do here?
Subtract.
Subtract, right. Can we just subtract right now, or do we need to do a conversion? We can just subtract, right? Because we have the given is 150 liters of oxygen, and then we know we need 105 liters of oxygen. So if we subtract them, we know how much is left over. How much is left over? 45. No. Just 45. Why? Because we're subtracting, right? And when you subtract or add with sig figs, it goes to the least number of decimal points, which is 0 for this. There's no decimal places for this. I know, it's tricky. Okay? So how many liters of excess remain would be the 45. All right? And then how many grams of water are produced in the reaction? What do we start with for this? The limiting reactant. Yeah, exactly. We're going to start with the limiting reactant, okay? What other thing could we start with besides the limiting reactant? And I'm hesitant to even ask this question, but you can start with something else.
105 liters.
Yes, you could start with the 105 liters of oxygen because you know you're going to use exactly 105 liters of oxygen, right? So you could start with that. But don't always start with your limiting reactant, all right? But I like that you understand the concept enough for that. What was our limiting reactant? The 10 liters of the heptene, right? So we have 10.0 liters of heptene. All right. And we're looking for water, right? And we're looking for grams of water. All right, so we need to convert that over. So on the bottom, we'll have our liters. So 22.4 liters of heptene. On the top, we'll have 1 mole. Okay. What's going to go on the bottom now? Yeah, 2 moles of heptene. C7H14. What's going to go on the top? Good. We're going to have moles of water. How many? It's 14, right? 14 moles of water. All right, and we want grams, so we'll put 1 mole of water on the bottom. And then what goes on the top? Yep, 18.02, right? 18.02 grams of water. And now we multiply, divide. You should get 56.3. All right, 56.3 grams H2O. And that's how much products. All right. Any questions with that in the format or any of that? No, you guys are okay with that?